Crash Course Instrumentation, Episode 39. What is a multimeter? What's the one tool you'll find in every technician's toolbox, from field service to fine electronics? It's the multimeter, the Swiss Army knife of electrical measurement. Whether you're checking a battery, verifying a signal, or diagnosing a fault in a control panel, multimeters let us measure voltage, current, and resistance, all from one handheld device. These days, almost every I&E tech is expected to have one and know how to use it well. It's not just about pushing buttons. It's about understanding what you're measuring, where to probe safely, and how to interpret what the meter tells you. So what exactly is a multimeter? The name says it all, multimeter. It's a meter that can measure multiple electrical quantities, most commonly voltage, current, and resistance. And depending on the model, you might also find features for frequency, capacitance, continuity, or even temperature. There are two main types of multimeters, analog and digital. Before we get into the meters themselves, it's helpful to understand the difference between analog and digital in general terms. Analog means continuous. An analog signal or device represents information using a smooth, uninterrupted range. Think of a dimmer switch for a light or the sweep of a clock's hour hand. Digital means discrete. Digital signals use specific values or steps, like flipping a light switch on or off, or reading numbers on a digital clock. In measurement, this means information is broken into steps and shown as numbers. Analog meters use a physical needle and scale to show the measurement. They're simple and surprisingly durable, but they take some skill to read accurately. As the signal changes, you can watch the needle move in real time, which helps some technicians spot trends or fluctuations quickly. Digital meters, on the other hand, use electronic circuits to convert signals into numbers and display them on an LCD. They're usually more accurate and much easier to read. A DMM updates its readout several times per second and may beep, hold data, or even calculate min-max values. The trade-off? You may not notice fast signal swings the same way you would with a moving needle. A bit of history. The first analog multimeters, often called VOHMs, for volt-ohm milliammeters, became popular in the early 20th century. By the 1930s, rugged analog meters like the Simpson 260 were standard equipment in labs and military applications. In fact, NASA engineers used them during the Apollo program. Today, digital multimeters, or DMMs, dominate the market, thanks to their accuracy, readability, and extra features. Some DMMs can even log data over time, helping identify intermittent faults or power fluctuations. But what are these meters actually measuring? Let's break down the big three. Voltage is the electrical potential difference between 2 points. Think of it like pressure in a water pipe. Current is the flow of electric charge, like the actual water moving through that pipe. Resistance tells you how much a material resists that flow, like a clog slowing down water. A multimeter can measure all three, and learning how to measure them safely and correctly is essential for any technician. So why are multimeters so important? Because they turn invisible things, like voltage and current, into real measurable values. You can't see electricity, but you can absolutely see a number on a display or a needle on a scale. And when you're troubleshooting an industrial process or checking loop integrity in an I&E system, those measurements are your eyes. For instrumentation and electrical technicians, multimeters are critical. Here's why. They're used to validate control signals in 420 milliamp loops, verify transmitter outputs, and confirm voltage at terminals. When calibrating equipment, a DMM helps ensure you're not chasing phantom signals or wiring mistakes. During loop checks, you'll often need to measure resistance to verify RTDs or check continuity across terminal blocks. And in hazardous or classified areas, choosing the right meter with proper CAT rating and explosion-proof design is not optional. It's life-saving. In short, if you can't use a multimeter confidently, you're not ready to work in the field. Quick safety reminder. Always check your meter's rating before measuring high voltages or industrial power. Look for the CAT rating on the case. It's there for a reason. Using the wrong meter in the wrong environment can be dangerous. Never trust a circuit is dead. Test your meter first on a known live source, then test the circuit, and test the meter again. It's called test before touch, and it's standard practice. Ready to go deeper? In our next episode, we'll open up the meter and look at the different jacks, functions, and selector settings. You'll learn why some meters beep, why others have fuses, and how to choose the right tool for your job. If you're enjoying this series, be sure to like and subscribe for more Crash Course Instrumentation. Share it with your classmates or coworkers, and join the conversation in our Facebook group. The link's in the description. Thanks again to Tony Kuphaldt and the open source community for making these resources possible. All our lessons are based on the incredible ModL collection at ibiblio.org.